Hello everyone, welcome back. Today I'll be going through all of the challenge questions in Edexcel's Pure Year 1 textbook, chapter 5. Okay, our first question is from exercise 5b. Show that the equation of a straight line through 0a and b0 is ax plus by minus ab equals 0. So first of all, we can find the gradient of the line, which you know is the rise over the run, or the difference in y over the difference in x, which in this case is a minus 0 over 0 minus b, which is minus a over b. Now we can plug this into our general form of a straight line. So y minus y1 is equal to mx minus x1. And our x1 and y1 here, we can choose from either 0a or b0. For here, I'm going to go for 0a. So our equation is y minus y1, which is a, is equal to the gradient minus a over b times x minus x1, which is 0. So we get y minus a equals minus a over bx. Multiplying both sides by b, we get by minus ab is equal to minus ax. And adding the ax to both sides, you get ax plus by minus ab is equal to 0 as required. Okay, our next question comes from exercise 5c. Consider the line passing through the points x1, y1 and x2, y2. Part A says write down the formula for the gradient m of the line. So, the gradient is the difference in y over the difference in x, so that is y2 minus y1 over x2 minus x1. Okay, part B. Show that the general equation of the line can be written in this form here. So, what we can do is we can use the general form of a line as we did in the previous question, and in this case x1 and y1 are just x1 and y1. So we get y minus y1 is equal to the gradient times x minus x1. And all we have to do now to get to the result they want is to divide both sides by y2 minus y1. So we get y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. And finally, part C, use the equation from part B to find the equation of the line passing through the points minus 8, 4 and minus 1, 7. So here our x1 is minus 8, our x2 is minus 1, our y1 is equal to 4 and our y2 is equal to 7. And plugging these values in, we get y minus y1 over y2 minus y1 is equal to x minus x1 over x2 minus x1. And so we get y minus 4 over 3 is equal to x plus 8 over 7. Multiplying by 21, we get 7y minus 28 is equal to 3x plus 24. And we can take all of these terms onto one side to get 3x minus 7y plus 52 equals 0. And that is our final answer. Okay, for mixed exercise 5, question 1. Find the area of the triangle with vertices A minus 2 minus 2, B 13, 8 and C minus 4, 14. So, first of all, we can draw a little sketch to help us. So, minus 2 would be somewhere here. 13, 8 will be somewhere up here. And minus 4, 14 will be somewhere here. So the triangle looks something like this. Okay, and we can label the points A minus 2 minus 2, B 13, 8, and C minus 4, 14. Okay, one way we can go about doing this question is to draw the perpendicular from one vertex to the opposite side. So for example, from C to AB, and let's call this point D. Now to find this point, we know that it has to be perpendicular to the side AB, and so it's the gradient of the line CD has to be -1 over the gradient of AB. And we can also use the fact that C minus 414 lies on the line. So let's do that. So finding the equation of the line CD. First of all, we know that its gradient has to be -1 over the gradient of AB. So first, finding the gradient of AB, we get 8 minus 2 or plus 2 over 13 minus 2 or plus 2. We get 10 over 15, which is 2/3. So therefore, the gradient of CD is equal to -1 over 2/3 or -3/2. Okay. Now we can use the point on the line, -414, to write the equation of the line CD out. So we get y minus y1 is equal to the gradient times x minus x1. So y minus 14 equals -3/2 x plus 4. So expanding and rearranging, we get y equals -3/2 x. So here we have -6 and we're adding 14 to that, so we get +8. And that is the equation for CD. Now to find the coordinates of the point D, we know that is the intersection of the lines CD and AB. So we need to find the equation of the line AB. So we have y minus y1 is equal to the gradient, which we have as 2/3, x minus x1, or y equals 2/3 x minus 2/3, and that is the equation of the line AB. So now we can solve these two equations simultaneously to get our value of D. So putting that straight into our calculator's simultaneous equation solver, we should get that x equals 4. Let's write those in. X equals 4 and y equals 2. And so our point D is 4, 2. Okay, so I've now written the point D 4, 2 on our diagram. And now to find the area of the triangle, we can do 1/2 base times perpendicular height. So the area equals 1/2 times AB times CD. So first of all, looking at AB, so this bottom side has length 13 plus 2, which is 15, and the other side has length 8 plus 2, which is 10. So the length AB is equal to the square root of 15 squared plus 10 squared, which gives us the square root of 325. And doing the same for CD. Here, the vertical side has length 14 minus 2, or 12, and the horizontal side has length 4 plus 4, which is 8. So the side CD has length the square root of 12 squared plus 8 squared, which is the square root of 208. Okay, and so our area is equal to 1/2 times the square root of 325 times the square root of 208, which gives us 130 units squared. Okay, question 2. A triangle has vertices A 38, B 99, and C 52 as shown in the diagram. The line L1 is perpendicular to AB and passes through C. The line L2 is perpendicular to BC and passes through A. And the line L3 is perpendicular to AC and passes through B. Show that the lines L1, L2, and L3 meet at a point and find the coordinates of that point. Okay, so first of all, we can find the gradients of the line segments AB, BC, and AC. So the gradient of AB is 9 minus 8 over 9 minus 3, which is 1 over 6. The gradient of BC is 9 minus 2 over 9 minus 5, which is 7 over 4. And finally, the gradient of AC is 2 minus 8 over 5 minus 3, which is equal to minus 6 over 2, or minus 3. Okay, so if we're looking at L1 first, L1 is perpendicular to AB, so its gradient M1 is equal to minus 6. And therefore, we can write the equation as y minus y1, so it passes through C, so that would be 2, is equal to the gradient times x minus x1, which is minus 5. So we have y equals minus 6x plus 30 plus 2 is plus 32. So this is L1. Okay, for L2, we know that M2 is equal to minus 1 over the gradient of BC, so minus 4 over 7. So using our equation for a straight line, we get y minus y1, which is 8, is equal to the gradient times x minus x1, which is 3. And so we get y equals minus 4 over 7x plus 12 sevenths plus 8, which gives us 68 sevenths. And that is L2. So finally, finding the equation of the line L3, we get that the gradient of the line M3 is equal to minus 1 over the gradient of AC, which it is perpendicular to. So that is 1/3. And using the same general form of the equation of a straight line, we get y minus y1. So this is passing through B, so y1 is 9. Is equal to the gradient times x minus x1, which is also 9. So we get y equals 1/3 x minus 3 plus 9, which is plus 6. And that is our equation for line 3. Y equals 1/3 x plus 6. So to find the point of intersection, we can choose any of the two lines to solve simultaneously. I'm going to go for L1 and L3 just because I don't really want to deal with the 1/7 in line 2 yet. So L1 and L3. Solving them simultaneously, we get minus 6x plus 32 is equal to 1/3 x plus 6. And taking them 1/3 over to the other side, we get minus 19/3 x equals minus 26. And so dividing by minus 19 over 3, we get x equals 78 over 19. And now plugging that back into one of our equations at the top, we'll go for line 3. So y equals 1/3 times 78 over 19 plus 6, which is equal to 140 over 19. And so our point of intersection is 78 over 19, 140 over 19. But we're not done yet because we still have to show that all of the lines meet at this one point. So all we've got to do now is show that x equals 78 over 19 and y equals 140 over 19 fit the equation for line 2. So 78 over 19, 140 over 19 is a point on L2 also. So plugging our value of x into the right hand side, minus 4/7 times 78 over 19 plus 68 over 7 gives us 140 over 19, which is our y value that we got for the point of intersection. So 78, 19, 140 over 19 lies on both L1 and L3, and we've also now shown that it lies on L2 as well. So all three lines must meet at that point, which is 78 over 19, 140 over 19. Okay, and finally, our last question, question 3. A triangle has vertices A, 0, 0, B, AB, and C, C0 as shown in the diagram. line L1 is perpendicular to AB and passes through C, line L2 is perpendicular to BC and passes through A, and the line L3 is perpendicular to AC and passes through B. Find the coordinates of the point of intersection of L1, L2 and L3. So this is very similar to the previous question. So we can start by finding the gradients of the line segments AB, BC and AC. So MAB, the gradient of AB is equal to B over A. The gradient of BC is equal to B minus 0 over A minus C, or just B over A minus C. And finally, the gradient of AC is equal to 0 because it is a flat horizontal line. Okay, so we can start by looking at the easy line. So that is the vertical line, which is going through the point B and perpendicular to AC. So this line, which is L3, is just the line x equals A. The next easy line we can look at is L2, which passes through the origin. And we know that L2's gradient is perpendicular to that of BC. So we know that the gradient of the line L2, M2, is equal to minus 1 over the gradient of BC, so minus AC over B, or C minus A over B. And so, because we know that the line passes through the origin, we know that L2 is y equals C minus A over B, x. Okay, and finally, the line L1, we know that the gradient M1 has to be minus 1 over the gradient of AB, which is B over A, so minus A over B. And using the general form of the equation of a straight line, we get y minus y1, which is 0, is equal to the gradient minus A over B times x minus x1, which is C. And so we get y equals minus A over bx plus AC over B. Now, find the coordinates of the point of the intersection of these two lines. Well, we only need to focus on two lines, so we'll go for L3 and L2. So, plugging in x equals A into the equation for L2, we get that y equals C minus A over B times A, or AC minus A squared over B. And we know that x equals A, so the point of intersection is A, AC minus A squared over B, and that is our final answer. And that is the end of the challenge question walkthrough for mixed exercise 5. Quite a long one, and I hope you enjoyed it.